Hi everyone, today we are talking about graphing a function. So you're going to remember a lot of this from Algebra 1 and Algebra 2. So I won't spend too much time today talking about it, but let's just all be on the same page and say that the graph of a function f is a set of points x comma y on the Cartesian plane, which is just like what you see right here. Okay, our Cartesian plane, you have your x-axis, your y-axis, where y is the image of x through the function of f. All right, so as you start to draw these graphs, you're going to want to draw a table of values to find some points on the graph. And then, of course, you're going to plot the points. And if they're like decimals, just get as close to possible. And then you're going to join your points with a line or a smooth curve, depending on the function. In our first example, we've got draw the graph of the function y equals negative x plus 1. So just like from Algebra 1, you're going to plug in your x values. I usually call these the Fab Five. Okay, your favorite x values are usually negative 2, negative 1, 0, 1, and 2. You want to make sure that you get some positive values, 0, of course, and some negative values. And for most functions, you're going to be using negative 2, negative 1, 0, 1, and 2 for your x values. So you're going to plug them in. Negative 2 plus 1, that gives you 2 plus 1, which is 3. Keep going. You got negative 1 plus 1. That's a positive 1 plus 1 gives you 2. And proceed on, and you're going to plug in 0 and you get 1 back. Plug in 1, you get 0. And plugging in 2, you get negative 1. So when you draw your graph, at negative 2, you're up at 3, which is about here. At negative 1, you're at positive 2. At 0, you're at 1. And 1 comma 0. And 2, negative 1. And then you're going to connect through. Whoop. Make sure that you use the straight edge. Student ID card works great for these linear graphs. And of course, we can talk about some of our information. You should remember that the point on the y-axis, where the graph goes through the y-axis, is called the y-intercept. And the point where the graph goes through the x-axis is called the x-intercept. So some of your problems will ask for you to write the x-intercept and the y-intercept, x-intercept and y-intercept. So you're going to give me the coordinates. X-intercept is 1 comma 0, and your y-intercept is 0 comma 1. And then a further question is to decide whether the point 200 comma negative 199 lies on the graph of the function. So remember, your graph goes on forever and ever and ever and ever. So how do you know if a point is on the graph of the function? Well, you're going to plug in the point. And you're going to plug in x is equal to 200 because that's an x value, and y is equal to negative 199, and see if the equation is true. If the equation is true, that means the point is on the graph. If your equation is false, then that point does not lie on the graph. So plug it in. You've got does negative 199 equal 200, so question mark. We don't know if they're equal. Negative 200, because there's a negative in our function. So negative times 200 plus 1. So does negative 199 equal negative 200 plus 1? And I would say that is definitely true. So since it is true, the point 200 comma, negative 199 lies on the graph. Our next example is similar, but they tell you that the point B, which has an x value of 6, and it's missing a y value, which we're going to be able to find soon, they tell you that point lies on the graph of the function. So we can find the value of y. What we're going to do is plug in what you know. What do we know? We know that x is equal to 6, and we're going to solve for our y. So in our equation, we have the equation y equals negative x plus 1. So plug in what you know, solve for what you don't. So negative 6 plus 1 gives you a y value of negative 5. So B, which would be the point 6, negative 5, lies on the graph. Our example 2 kind of flips it around. So they give you the graph of the function of f, and you need to state some information like the domain, the range, where the graph hits the x-axis and the y-axis. So when we look at our domain, we're looking at all the possible x values. So you want to look left to right. So is this x value of negative 6, oh, let me make it a little darker, of negative 6 defined? Is there a piece of the graph that has an x value of negative 6? And you would say, yeah, it's like all the way up here, right? Same value, same thing with negative 8. Negative 4 is defined somewhere around here. Negative 2 is defined at 0. 0 is defined down at negative 4. 2 is defined, right? All the way. So all of these x values are all defined, but then the graph kind of ends right at positive 3. And because there is an open circle, it is defined at 3 and should be colored in. But if you notice, if you continue on to the right, if you look at like 6, is there a piece of the graph with an x value of 6? And you would say no. So that 6 is not a piece of the domain. Our x values are actually only defined up until 3. From negative infinity up until positive 3. So how do we write that? We can use the fancy notation, the function, for all values of x such that x is less than or equal to 3. So that might be a new notation for you. You're probably used to just x is less than or equal to 3, but this is called set notation. And they introduce that kind of right now. Now for our range, let me erase all that green. We've got, okay, I think I've got just about it all. Oh, nope. Okay, I'll leave that one there. For our range, we need to look at all of our possible y values. So you'll see this y value of 8 is defined over here. This y value of 6 is defined over here. This y value of 4 is defined over to the left, so on and so forth. So all the way down, all of these y values are defined. Specifically, this x value of 0, or the y value of 0, is defined in 2 locations, but that's okay. Keep going. Now, when you get to the 4, because it's a closed dot, it is defined. That y value is defined with an x value of 0. But as you continue on, you'll see the graph does not continue down below, -4. So our range is really the function is equal to for all values of y such that y has to be greater than or equal to -4. So you kind of look and see what's the lowest that graph goes. It has the lowest value of -4 right there and goes to infinity. When you're looking for your x-intercepts and your y-intercepts, as in part C, you want to look and see where the graph hits the x-axis and the y-axis. Let me erase a little bit, clean it up a smidge. Delete that. Okay, so let's look for our x-axis or x-intercepts. That's where the graph hits the x-axis. So let me highlight it. We've got, here's our x-axis, you've got an x-intercept of 2 and -2. So you're going to tell me those coordinates, which are -2, 0 and 2, 0. So you actually have 2 in this function. And then our y-intercepts are any places that the graph hits the y-axis, which is right there at that -4. So tell me the coordinate. You've got 0, -4. In example 3, so let me just go over a few vocabulary words that the book decides to do. If you see, like in the first example, draw the graph, it really wants you to plot points on a graph paper and make it nice and pretty. Get your Fab 5, plug them in, and then get a nice pretty graph. Now, in example 3, they say the word sketch. So sketch the graph. All you need to really do in a sketch is to give me the general shape of the graph and get it in the right location. So yes, you could use your slope and your y-intercept, use y equals mx plus b. But for a sketch, really all I technically need is your x-intercept and your y-intercept. So if you think about it, any x-intercept, any point along the x-axis, okay, has a y value of 0. So if you want to find the x-intercept, you're going to plug in y equals 0 into the equation and solve for when your graph hits the x-axis. So you'll see 0 equals 3x minus 1 and solve that. Add 1 to both sides, so you get 1 is equal to 3x, and then divide both sides by 3, and you get x is equal to 1/3. So for a sketch, you're just going to give me the general shape. So here's your x-intercept at roughly 1/3, greater than 0, less than 1. And then your y-intercept, if you think about it, any graph along the y-axis is going to have an x value of 0. So you're going to plug in x is equal to 0 into your equation and solve. So y is equal to 3 times 0 minus 1. And that's a y value of -1. So your graph hits -1 on the y-axis and 1/3 on your x-axis, and sorry about that, just give it a little sketch. So use your ruler, give it a straight edge. Let's see if my graph will work. Nope, that one didn't work. Let's try again. And maybe angle it a little bit better. There we go. So there's your graph right there. Kind of faint, but I think you can see it. All right, so that is a quick, simple graph your equations of lines type of lesson. All right, So email me if you have any questions or hangouts.